Hi, this is just a little review that goes over the worksheet that you were given in class in Algebra 2 to just review some exponential equations and log equations. So the first thing that we've been doing in this chapter is we've been graphing inverses. So this question asks us to graph the inverse, describe the domain, the range, the asymptotes, and the end behavior. So when we graphed our inverse, you looked at this first graph and you recognized that the points were switched. So I have the point 0, 1, so that must mean that I have another point that is 1, 0. And we talked about how the exponential curve will kind of follow the same pattern. This point looks like it's 1, 3, so I'll have another point at, it's actually 2.7, but I have another point at about 3, 1. And so our inverse, we said, was a reflection over the line x equals y, or y equals x. So that's kind of what our graph looks like. Number 2 will look very similar. It just goes through different points because it's 5 to the x. We've talked about the domain, but the domain of this orange graph is all x values are positive, so our domain is x is greater than 0. Our range, because the graph goes down and the graph continues to rise, our range we can write as interval notation from negative infinity to positive infinity, or a lot of the times in class we just said all real numbers. The asymptote is, what does this orange graph approach? The orange graph approaches the y-axis, and if we wrote that in equation form, that would be x equals 0. So those are things that we talked about most frequently this chapter. The other piece that we have written on here is end behavior, and we haven't talked about that in a while. But when we did talk about end behavior, we talked about as x, and we talk about it kind of what happens. X goes to the left, but as x approaches 0, because it doesn't get any negative numbers, what happens to your y values? F of x, the y values, approach negative infinity. The graph goes down. So as the x values get smaller and smaller, the y values get more negative. If you talk about as x approaches infinity, so as it moves to the right, what happens to my y values? My y values, or f of x, continues to grow or go towards positive infinity. So the question number 2 looked very much the same, but again, this is just referring to our domain. Our domain is all values that are positive. Our ranges go from negative infinity to positive infinity. So that's our first question. I'm going to move on and just do 1 or 2 questions out of the next section. The next section, all you had to do was rewrite. You did not have to solve, you just had to rewrite. So I'm just going to go through and do question number 3. Again, your answer for a log is the exponent. So I would have 9 with an exponent of negative 2, and that equals 1 over b. A problem like number 6 is already in log form, so very similar to number 3. But we have to remember that our base here is e, so the exponent on e is 0.058. And what does that equal? That equals the letter z. 7 and 8 ask us to rewrite from exponential form to log form. So again, I like to start with the exponent is on log b, so the exponent on b, that gave me 8. So those are just a few examples of that next section. The third section on this first page was to take the values, and I'm just going to take this first one, to take the values and first create an exponential equation that's true. So for example, if you did 2 to the 8th, that would equal 256, and then you're doing the same thing that you did in the section above, and you're writing that in log form. So again, exponent on, so log means on what? On log of 2, that gave me 256. So those are just some examples from the first page. Take a minute, look over them, see if there's any other questions that you could maybe bring to class or ask your teacher, and then we're going to turn to the second page. On the second page of the review, we were solving a lot of exponential and log equations. So I just want to go through a few of them that we've seen in class and that we practiced together. So the first problem I want to look at is question number 11. And we talked about in class that if both of these numbers are known, so when I look at this, both of these numbers are known, I can use the change of base formula. Oops. I can use the change of base formula. I'm not quite sure what I just did there. So give me a second to go back. Okay. So we're going to use the change of base formula for question number 11. And again, when we use the change of base formula, it's just the log of your answer, so the log of 343 divided by the log of 7. So whenever you're given both values right here, all you have to do is then plug this into your calculator. Log of 343 divided by log of 7. I'm doing that in my calculator right now. And I actually get an answer of 3. And so that's why if you look on the answer key, n equals 3. So if the values are known, like in number 12, you don't have to worry about doing any conversion. You just type in or use the change of base theorem. Question numbers 13 and 14 look like your homework from 11.3. So we're just going to go through one of those and then one of 15 and 16. So again, here, it's not in log form. I can't just apply the exponent. There's a x in the exponent. When there's an x in the exponent, I'm going to rewrite it in log form. So the exponent on 7, so that's log base 7, that gave me 28. So now when I look at this log form, I notice there are no variables, so I'm going to use the change of base theorem again. So this is the log of 28 divided by the log of 7, and that equals x minus 2. So I'm going to type that in my calculator, log of 28 divided by log of 7, and I get a decimal. I get x minus 2 equals 1.712. Now I just have to add 2 to both sides. So my answer number 13 is x equals 3.712. I would complete question 14 the same way. Questions 15 and 16 are very similar. The exponent on 9, so log base 9, that gave me 124. Again, there are no exponents or no x values on this log side, so I'm going to use the change of base. So 3x equals log of 124 divided by the log of 9. Type that into your calculator, so log of 124 divided by log of 9, and I get again a decimal, 2.194, it looks like if I round, 194. Divide that by 3, so for problem number 16, x equals 0.731. The last few problems on this page are what we started doing, or reviewing, I should say, in class today. So I'm going to do problem number 17 with you. Again, this is in log form, but there's x's present, so I'm going to rewrite it in exponential form. So 2 to the first equals x squared minus x. So the exponent on 2, well, I know that 2 to the first is just 2. And then we talked about in class that this is 2 different types of x's, so we're going to have to set it equal to 0 and solve a quadratic. So I subtracted 2 from both sides. To solve a quadratic, you could factor, you could use the quadratic formula, you could graph. I personally find factoring to be my first choice, and I know things that multiply to 2, negative 2, and add to negative 1. So that would be a negative 2 and a plus 1. So that means for number 17, x equals 2 and x equals negative 1. That's how we came up with those two values. 18 and 19 are solved the same way. So again, take a minute, look through these pages, see if there's any other questions that you have for your teacher and bring those in to help you review. Okay, now take a minute and turn to page 3. On page 3, we had a lot of application questions, and after talking with Mr. Whalen this morning, we decided that we really aren't going to focus on 20 and 21 right now. You'll see a lot more of that in pre-calc or in transition to college. And so it was a 2-step problem, and we just felt like we weren't quite ready for that. So I'm going to actually focus on the last 3 word problems on here. Oops, 3 word problems. And we'll walk through those together. So using the exponential formula equation to answer the question. So they're giving you formulas here. So the number of students exposed to measles at school can be modeled by this equation, where S is the number of students exposed after T days. How many students were exposed after 8 days? So all they really want you to do is take your equation, S equals, must have been 10 students that started, E, the rate looks like it was 15%, and we're doing 8 days, so you just plug in 8 and find out how many students were exposed after 8 days. So 10, E is again a number, so you just use that on your calculator, to the 15th times times 8. And it turns out that if I round to the nearest whole person, again, it gave me 33.201, but basically after 8 days, 33 students would have the measles. So we're just using the equation. So 23 is the same thing. Aiden invested $600 into a savings account with continuous compounding interest. The equation V equals 600E raised to the 0.05T can be used to predict the value of V in Aiden's account after T years. Well, how much money or what would be in his account after 5 years? So again, V equals 600 was his starting amount. E for continuous. He must be getting 5% interest, and we're just plugging in 5 years and then plugging that into our calculator. So 600 E to the 0.05 times 5, and it turns out that after 5 years with 5% interest, he would have $770 and looks like about 42 cents. I'm rounding up and assuming that Aiden will get that. So just reading the question and filling in the blanks. Question 24, the rabbit population on Hare Island can be modeled by this equation. R represents the number of rabbits. How many years will they have until there's 177 rabbits? So 24 is a little different because they're telling you that R is 177, 60E, 0.09 must be the rate, and T. So you must solve for T like we were doing in class. So the first thing you're going to do is divide by 60 on each side. So 177 divided by 60 is about 295. Where's my cursor? 2.95 equals E to the 0.09T. Now this is an exponential form, so the exponent on E, and I can write that as ln, that gave me 2.95. I can plug ln, again because it's an E, right into my calculator, so ln of 2.95 gives me a nice number of 1.082. And then I'm going to divide both sides by 0.09. If I divide both sides by 0.09, it turns out that it will take approximately 12 years for the rabbit population to go from 60 rabbits to 77 rabbits. So that's just, again, a very brief walkthrough of what we've been doing this chapter and just questions from the review. If you have other questions, please come in, see your teacher as you're going through it. Thanks.